We have been working with linear systems, and we've learned how to solve them by graphing. We've learned how to solve them by substitution and by elimination or linear combination. And in that case, you'll get the number one there where lines intersect. You'll get one solution. Well, there's a couple other what we call special types of linear system when lines are parallel, which means they have no solution because they will never cross. And in this case, the lines will have the same slope but different y-intercepts. So in a solution like I have, or in a problem like an example like I have on the bottom here, what I can do is a couple different things to solve this. One, I can put this in the slope-intercept form and see if the slopes are the same. Or I can just solve it. If I solve it, let's solve this one by, let's use elimination here. So we're going to take this top equation, right, and we're going to multiply it by a -2. Right, so we'll take negative 6x plus 2y is equal to a -8. So that's actually the top equation. The second equation then would be a positive 6x, minus 2y, right, is equal to 7. Now when I add these two systems together, we end up with 0, right, over here is equal to 7. And again, in this case, it is not true, right? And so if it's not true, if we end up with this situation where my variables all cancel and it's not true, then we have lines that are parallel, and so therefore we have no solution. Another way to double check this again is to put them in the slope-intercept form. So let's take the second equation first and put that in the slope-intercept form. So this would be y is equal to 3x plus 7. So the slope of that line is 3. So if we can get a slope of 3 in the other line with a different y-intercept, then we know these two lines are parallel. Take the second equation, negative 6x plus 2y, or should I say the first equation, is equal to a -8. Let's solve this for y. So we're going to have 2y is equal to 6x, all right, minus 8. Divide everything by 2. All right, divide everything by 2, and we end up with y is equal to 3x, all right, minus 4. So they have the same slope. They have different y-intercepts, so these two lines are parallel, and therefore we have no solution. So there's two ways to check it. More than likely, you're going to do the first way because you're going to be trying to think, you're not going to know that there is no solution to this system, so you'll probably solve it by substitution or elimination, and in that process, you'll find out that it's no solution. A way to check it would be to do the second method where you put them both in the slope-intercept form and make sure that their slopes are the same with different y-intercepts. Second type of special situation in linear system is when we have infinite many solutions, which basically means we have two lines that are the same. They'll be right on top of each other. As you're solving a system, so let's solve this system by elimination. We'll take the first equation and we'll multiply it by 3. First equation multiplied by 3, so we get a -3x, right, plus 6y is equal to a -6. Second equation, we'll write right below it, and we're going to add them together. So we got 3x, right, minus 6y is equal to 6. Now when you get this situation where you're going to have infinite solutions, you'll see what happens. We end up with 0 on this side is equal to 0. So when you get the situation when two numbers equal each other, then you have infinite solutions. These are the same lines, so they lie right on top of each other. So in this case, our answer here would be infinite solutions. In our third example here for special systems, you're going to be looking at a system, and again, you're going to solve the system either by substitution or elimination, and as you solve it, you're going to need to interpret the results. So in this one, we're going to solve this system. We're going to multiply the second equation by 2 so we can eliminate y. All right, so we end up with 6x, all right, minus 2y is equal to 10 is our first equation. Our second equation, we get negative 6x minus or plus 2y is equal to 24. So in this situation, we're going to get 0 on this side, so 0 is equal to 24. That is untrue, so therefore these two lines are parallel and we have no solution. And this is what you're going to be doing when you're doing these. You're going to be solving these thinking that there's a one-point solution, and all of a sudden as you go through the problem, you're going to see that you're either going to get 0 equal to some number and you know it's no solution, or you're going to get 5 is equal to 5 or 0 is equal to 0, and then you'll know that it is infinite solutions.